Good day, everyone. My name is Ravina Kanhai, and today we will be looking at understanding IPv6 network addresses. So, before we look at IPv6 addresses, I just want you to remember that we previously learned about IPv4, which has 32 bits. So, what is our IPv6 addresses? These are addresses that have 128 bits. These bits are represented by a colon-separated hexadecimal notation. And in this notation, each hexadecimal numeral is the equivalent of 4 bits or 8 hexadecimal. These addresses can also be represented by a slash notation of 64. So, if we look at the structure of an IPv6 address, we have our network part and our node part, which is our broadcast. And in this, it is separated by 48 bits, 16 bits, and 64 bits. Let's look at an IPv6 address and make sense out of it. Each of these addresses ranges from 0 to 9 and A to F. These addresses, as we mentioned before, were split into network and host. So our network and our host. Then we can even compress these addresses by replacing the 0 with colons, but they can only be used once per address. So for example, let's just show the example here. We have our network address, our IPv6, and to condense and compress this IP address, what we did, we simply replaced our double zeros with 2 colons. So as we refer to here, we have our group, our digits, our colon, and our bits. And there are 8 groups, 4 digits in each group, and 4 bits in each digit. And these make up our 128 bits in our IPv6 address. So, how do we subnet an IPv6 address? Before we go into the subnetting, we must understand that there are different types, and we must be able to recognize these different types of addresses. So we have our unicast, multicast, and anycast. So usually our public address is represented by 2000/3. So these are any address that are public. Then we have addresses that goes with our FC00:/7. These are our routable addresses used in our LAN. We also have our FE addresses. These are not routable addresses. Then we have our FF addresses. Here, our assigned addresses, which is used to represent groups. And last but not least, we have our anycast addresses, which is our 2000/3 as well. So let's go now into the subnetting of an IP address. So here we have our IP address. And this IP address is as shown below. As you remember, IPv4 addresses are written with decimal numbers. Different to IPv4, our IPv6 address is written with hexadecimal digits. And it is important to note that there are only 10 numbers in the decimal numeral system. So when we are numbering, when we are writing our digits, we combine the range from 0 to 9 and A to F. So the IPv6 address consists of 8 groups separated with colons, and in each colon there are 4 digits. Each digits are created with 4 bits to become 128 28. So in this address, our IP version 6 has 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. And each of these groups is separated by a colon. Within each group, there are 4 digits. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and so forth. Each of these digits can be created with 4 bits. So in total, we now have 128-bit addresses. So what we can do for this address is drop the zeros. So if I were to drop my zeros, I will just show you here. The process of dropping zeros, my IP address now becomes 2345 colon 425 colon 2 CA 1 colon 0000 0000 567 5673 and 23B5. So here we dropped our zeros and we made our IP a little smaller. In addition, we can now use a zero, eliminate the zeros for the entire group. So in the IPv6, a group can consist of all zeros. And in this case, we do not need to write all the zeros. So here we're seeing double zeros, but we do not need to write all these zeros. So what we can do, we can, as mentioned before, use a colon and separate them. So we can now get 2345 0425 to CA1, our 0 0567 5673 23B5. So now we have replaced our zeros here with a single zero. There can also be many zeros in a group. So to write all these zeros are usually difficult for IP addresses. So now we have our situation where we use our double colon. And we use these double colon to shorten all the zeros in the addresses. So in other words, if we have an entire field of zeros, we can only use 1 0 for each colon. This is the important point. Here, we can only use a double colon once in our IPv6 address. So here now, we are going to use our zeros, use our double colon. So the fourth step now to compressing this IP address is our double colon. So we're going to use 2345 0425 to CA1. That was capital A. So this was supposed to be a capital A as well. And here we insert our double zeros to replace our zeros, and we go 0567 5673 and 2365. So here, instead of writing 0000 colon 0000, we simply replaced it with our double colon. right? So we replace this with this. So now let's look at this IP address. And we want to subnet this IP address. So remember, we spoke about using our values such and our range, which is 0 to 9 and A to F. So when we subnet this IP address, using this address, our starting range is 2345 colon 0425 colon 2CA1 colon and our zeros. Now remember, we can simply apply our double colon procedure to the zeros. And bearing that in mind, our end range now becomes an ending of FFF, F, FFFF, FFFF, and FFFF. Now, the last thing I want to show you is a simple subnet calculator using Excel. So as you can see here, we have two IPv6 addresses. Now, in order to calculate it, we simply plug in our binary values. So remember, with binary, we use 8. Now we are using our hexa, right? So all we are simply doing is adding. So just like we would add with binary, we simply plug in our values to represent each of our bits and we simply add down. So this can be simply done on an Excel calculator sheet, or we can use an IPv6 calculator, and all these values would be able to be seen. And that's all for today. Have a great day. Thank you for watching. Bye.